Okay, hi, my name is Aravinder Anakish Tambaram, and matrix number is CE200100. So today I'll be presenting my part is for project 2. So the project is determining the circuit model parameters of three-phase induction. So this is my part, as you can see here. My part is test 1 DC test of three-phase induction motor. So this is a circuit that I'm going to simulate in MATLAB. Okay, so let's go. So first you need to click MATLAB. Okay, then you need to go to Simulink. Press Simulink. Uh, then this block will be. Yeah, I mean sorry, this page will appear. So now you need to create the circuit diagram. So you can refer uh, the rubrics, make the report given to us. So this is a circuit, and then you just need to do the same circuit on the MATLAB. Okay, so before that, let me explain how you can get this component. So you just need to click library browser, and then you just type, let's say display, you type display and enter, then you can find it. So as you can see here, so you need to scroll down and find the component that you want. So that's many component you need to. Oh, you see this is the display that you have. So, okay, next is for the next part is, as you can see the report. Okay, so next part is developer simulation, and select the type of assigned type is synchronous ratio. Okay. So for this, every group has assigned the type of a synchronous machine. So you can get the synchronous machine from this. What this is given. So I'm group 2, so we'll be choosing 09. So now before you do, you need to click here, double click, and then you need to remember this rotor type is squirrel cage, and then this is the part you need to think. So as you can see, there's many. So for group 2 is 09, which is 10 HP, 57 voltage, 6 years, 1760 R. Then we just apply. Okay. So for the next step is you can refer back the code. As you can see, run the model, 10 seconds to record the IDC and VDC. Okay. So next part is you need to go to MATLAB, and then press here 10 seconds. As you can see here, I'll keep pressing, and then you just need to run. You just click command, right? Okay, so this is the value. As you can see here, the display is 2737, and the display one is 5. So you can go back here, and so we get the IDC and VDC. So that's all for me. Thank you. Okay, for next part, I'll explain about how to calculate the value of stator, which is stator resistor, which is R1. So as you can see, this is the formula for R1, 0.5 times VDC over IDC. So we already get the VDC and IDC. So you just need to take this value and apply on the formula. So this is the value for the R1. So it's 913.41 milliohm. So that's all. Yes.
Hello, my name is Avina Mariel and my card metric number is CE200108, and today I'll be presenting for the block roto test for project 2. So we will start with the um, three-phase sine generator, where we have placed the magnitude block, the angle and the frequency block. So based on the question, we have placed for magnitude is 2 times square root 2, and the angle is 0, while the frequency is 50 Hz, which is then connected with a Dmux bar here, where it is connected to 3 voltage source, where we have labeled it as VAA, VBB and VCC. It is then connected to the VI measurement and to our squirrel cage motor. As for the value, we have set the preset model is 09, which is 10 horsepower, 575 volts, 60 Hz and 1760 RPM. The mechanical input is speed and the reference frame is rotor, and it is then connected to a bus selector, where the first terminal is where we're going to measure the torque, which is in Newton meter unit, and next is the rotor speed, where the gain we have set to 60 over 2 pi, and both of these terminal is then connected to the displays. So as for the measurement, where we want to measure the voltage and the current for ABC, is then connected to the RMS block, so that we can display our VPH, our V phase and our I phase. And this is our power model for us to measure our power and our reactant power, our real power. So since we will not be measuring the reactive power, so I have placed the terminator for the reactive power, but for the power is connected to the RMS block and to our display. So that's all, and before is to measure our output. So the stop time is 10 seconds and we shall see the output. Alright, so we have gained our output, where our voltage is 2 volt. There will be 3. Yeesh. So in order to calculate the value of our equivalent resistance, which is Re equals to R1 and plus R2, and then we will need to calculate our R2 by using the value of R1. So in order to get R2, where the formula we will use our RLR minus R1. The value of RLR have gotten from our timetable, our data, and the value of R1 is from the previous test, which is the DC motor test, where we have gotten 915.751 milli. So minus both of that value, we have gotten 3.611 ohm. As for the second calculation is to find the value of x1, x2. So x1 is equal to XLR, which we have gotten also from the data from the above, over 2, where our value for XLR is 16.77 over 2. We have gotten 8.385 ohm. Since our x1 equals x2, so both of the value is 8.385. That's all for me. Thank you.
Assalamu alaikum. I am Bashar Mustafa Ali Muhammad, matrix AE200076. I'm going to present for the induction motor test 3 for no load. We are going to show the values of the induction motor test. So we run. So now we will see the values, and the time is 100 seconds as asked in the question. So we see the values. This is for voltage 220, and also here for the V phase, and here is for I phase values, and for 3-phase induction motor, and also this one for PCS. Okay, and this one is the output of the induction motor. So that's for simulation part. Now we see for calculation. So now for calculation, uh, this is the model of the motor that required for our group. And for the calculation, as you see here, for V phase, we it's the summation of the all V phases over 3. We get 219.9333. And for I phase, we also the summation of the all phases over 3, we get 3.1 approximately. And for Z equivalent, V phase over I, so we get 17.9677 ohm. So now we calculate for XM. For XM, we minus, which is 17.9677 minus 8035, so which is the X1, so we get 62.3127 ohm. And now for the PSC losses, which is 3 multiplied 3.1 squared multiplied 0.9134, so we get the power loss, which is 26.33 watt. For PROT equal 254.6 minus 26.33, so we get 208.27 watt. That's all for my part. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Hamzah Azri Amruddin, and my metric number is CE210143. Okay, so for the project 2, I want to present for my part. There is torque speed characteristic of 3-phase induction motor. Okay, so we proceed with the first procedure. Okay, step by step using the video. So after the video, I already done this circuit. Okay, and this one I get the value. Okay, so I want to show how I do the circuit. Okay, first open the MATLAB. And okay, let's say I want to find any things here. Okay, so just put in library browser and put like XY graph. Okay, XY graph. Okay, so just click this and drag to this. Okay, there is example to find the things here. Okay, so I try to run this. I try for the 20 second. Okay, so I get the value. This is 5549, 5598, 608.7. So it's near the 575 because we take for our model we need to do is 10 HP, 575 volt, 60 Hz, 1760 RPM. So we get the nearest voltage here for 575. Okay, so okay, to find this, so we do the face to face. And there's okay, for the graph, after we run, we can see the graph here at XY graph. Okay, so this is the graph. How to find the torque max? Just click here and here, and we just find the max. Okay, so the highest is the 226.21. Alright, here. Okay, like that we can find the torque max. Okay, Okay, so for the calculation, we move to here. So find the slip at the pole out top. So first we need to find the V pace. So we add all the voltage we get here and times 3 because got three reading. So we get this 574.47 volt. Okay, so for the next we find the I phase. So same like the V phase, just sum all and divide by 3. So we get 90.11 ampere. So then next PSC to P in. So we get it from here. That is 118619.5. Okay, so top max grade is 226.2. I show you just now. And okay, from that we find the synchronous speed. Formula is 120 FE per P. So we get 1800 here. And next we find the X max. There is 1234.4 that we get from the graph and divide by 1800, that is synchronous speed. So we get this 0.6858. Next we find WM is 1 minus 0.6858. Okay, we continue. We continue for the present. Okay, so we find WM is 1 minus 0.6858. That is get from this aspect times 1800, that is synchronous speed, and times 2 pi per 60. So we get 59.23. So we find P convert equal to T in times WM. That is so 226.2 times 59.23, we get 13397.83 watt. Okay, so for the last one, P out, for the P out is equal to P convert. So P convert is 13397.83. So the P out is same for with the P convert. Okay, this is example of per phase equivalent circuit. And the last one, the efficiency of the induction motor. So we get this P outs per P in times 100%. So 13397.83 divide by 118619.5 times 100%. So we get 11.3%. Okay, that's all from me.